Now moving on to the second exercise in this lab session, we've moved to the flow regulator test section. We're going to do two exercises here. The first one, we're just going to look at the relationship P equals RQ squared. P we're going to measure. For Q you're going to measure the velocity and calculate Q. So R theoretically should be a constant, and you're going to take a look at that in this exercise. Let me show you the setup here. So for this exercise and all the rest of them, we're going to have two manometers set up. We have one manometer set up at the pitot tube traverse section that we did previously, and we're just going to be recording centerline velocity pressures there. You'll calculate the centerline velocity, and then you'll multiply that by the correction factor to get the average velocity in the airway. And then you'll multiply that in most exercises by the cross-sectional area to get Q. This is the frame where we're going to put in the flow restrictions. And then what we're looking at for P, we're looking at the change in static pressure throughout the rest of the airway. So we're a little bit ways down from where we put in the restrictions to let the flow equilibrate in this region. So this pressure tap is connected to the positive side of our manometer. Air flows down to the end, up above, back to the discharge, and we take another pressure reading at the discharge. Remember, air always flows from a region of high pressure to low pressure. So that's the negative side of the manometer, and that's the positive side. So this is the data sheet for this exercise, and we have the regulator sizes on this left-hand column. I've already filled those in. The flow regulators are squares cut out of plexiglass, and the biggest one is 3 3/4 inches square. They decrease by 1/4 inch down to 2 inches. So I filled that in already. Then we have the centerline velocity pressure, which we record up there. I'm not going to show that. I took a couple of readings already. And then we have the delta static pressure. So that's the pressure differential that I just showed you going from this pressure tap up to the discharge. So that's going to be P in our relationship of P equals RQ squared. Okay? It's the change in static pressure as we go down the airway. So to take the data, our first data point is at full flow, so I don't have any of the regulators in. I've already recorded the velocity pressure, the centerline velocity pressure up there, 1.151 inches. Now I'll see what delta static pressure is. Again, I start the averaging function for the manometer. And I didn't talk about this before, but we will email you filled in data sheets with all of this data. Okay, so you don't need to try to record anything I'm writing down here. I'm just showing you how we would do the exercise. Okay, so the delta static pressure at full flow is 1.880 inches of water. So I write that down here under delta static P. Now I'm going to put in the first flow regulator. So I take out the blank, put in 3 3/4 inches square. I've already recorded the velocity pressure for this regulator, and it dropped by quite a bit. It went from 1.151 down to 0.832 inches. So again, that's the centerline velocity pressure. And now delta static pressure. Take that reading. That is 1.456 inches of water pressure. Okay? So I filled those in. So centerline velocity pressure, delta static pressure. We'll just do one more here. So now this is going to be 3.5 inches square. Again, I've taken the centerline velocity pressure already, and that is 0.723 inches of water. And my delta static pressure is 1.242 inches. Okay, so you can see pretty quick to just go fill out the rest of the data sheet for each of the regulators. The centerline velocity pressure is going to decrease. Understandably, we're blocking the flow with the smaller and smaller regulators, and the delta static pressure is also decreasing. So just note that we're not changing anything downstream from here. So everything down there where we're looking at delta static P is not changing. We're just using the flow regulators to change the flow rate. And again, in your analysis, P is just the pressure that you recorded, delta static pressure. For Q, you're going to calculate the average velocity as we discussed last time. You'll multiply that by the, so you'll record the velocity pressure in the center line, calculate the velocity, multiply by the correction factor to get the average velocity. Calculate Q by dividing the average velocity by the cross-sectional area of the airway, square that, and then what you're really looking for is R. So P varies, Q varies, R is supposed to not vary, and that's what you want to take a look at and comment on your results.